If you're someone who thinks about our place in the cosmos, you've definitely heard the name Theia.
Oh, absolutely. The massive Mars-sized planet that slammed into a young Earth, what, 4.5 billion years ago?
An impact so huge it completely destroyed Theia and created the moon from the debris. Just an incredible event.
It's the most important collision in our history for sure.
Yeah.
But the main character in that story, Theia, was just gone, wiped out.
But not really gone. Its fingerprints are still here, locked away in lunar rocks and deep inside the Earth's mantle.
Right?
And so for our deep dive today, our mission is to reverse engineer that collision. We're asking, what was Theia made of? And where did it come from?
And we've got some amazing new clues thanks to a study in the journal Science from researchers who basically used forensic chemistry to solve this.
So to start, where do they even begin? The first major hurdle is that Earth and the moon are compositional twins, right?
They're twins. I mean, earlier studies already showed that for elements like chromium and calcium, they're basically identical.
Okay, wait. So if they're identical, how can you possibly tell which ingredients came from the early Earth and which came from Theia? It sounds like you're trying to unscramble an egg.
That is the perfect analogy, and the answer is isotopes.
Ah.
Think of isotopes as variants of an element with slightly different weights, and that tiny difference acts like a chemical GPS tag.
The GPS tag?
Yeah. In the early solar system, the isotope ratios were a little different depending on how far you were from the sun. So you measure the ratio in a rock, and you can map it back to its original home address in the solar system.
That's an incredible tool, a kind of invisible archive.
It is. So this team measured iron isotopes in, I think, 15 Earth rocks and 6 lunar samples from the Apollo missions, and with just unprecedented precision.
And what did they find?
They confirmed it. The Earth and Moon's mix is indistinguishable, no question about it.
So if everything is all mixed together, you have to work backward mathematically.
You have to model it, exactly. You have to ask, what version of early Earth plus what version of Theia could possibly result in the identical mix we see today? And to do that, you need a filter.
And that filter is something called element segregation. Can you break that down for us?
Of course. So when the early Earth was a hot ball of molten rock, the really heavy stuff, especially metals like iron and molybdenum, they sank.
They sank right to the center to form the core.
Right. It's called segregation. And once that core formed, it was like a sealed vault. The original iron was locked away for good.
Okay, so this is the key. Any of that heavy iron we find in the Earth's upper mantle today?
It must have arrived late. Must have arrived after the core was sealed.
On Theia.
On Theia,
Yeah.
exactly. So mantle iron is a clean chemical tracer for Theia's ingredients. Meanwhile, other elements, like zirconium, which didn't sink, they tell the story of the whole planet's history.
So you combine the clues from iron, zirconium, all these different elements, and you can start to build a profile of Theia.
You can reconstruct its origin story. And this is where the puzzle pieces really start to snap into place.
All right, so this is the big reveal. What did their reconstruction of Theia tell us about its home address?
The analysis points very strongly to one conclusion. Most of the building blocks for both planets came from the inner solar system.
So a local.
A local, yeah. Theia wasn't some rogue planet that hurtled in from the outer solar system. It was an embryo that formed nearby. Earth and Theia. They were neighbors.
That's a huge confirmation for the local origin hypothesis. But the paper had a twist, didn't it? It was a little more specific than just neighbors.
It did, and this is what's so fascinating. The calculations suggest that while Theia was a neighbor, it actually originated a bit closer to the sun than Earth did.
Closer to the sun, wow.
And maybe even more surprising, its reconstructed makeup includes traces of material that, well, doesn't really match any of our known meteorite classes. It suggests Theia was built from stuff we haven't seen before, a previously unknown building block.
So, to put it all together, isotope analysis has let us chemically resurrect a planet that was destroyed billions of years ago.
And it showed us that the cataclysm that created our moon was, in a way, a local affair, a collision between two neighbors.
And if we think about what this means for you, listening right now, it's just a huge implication. Theia formed slightly closer to the sun and contained building materials we can't even identify yet.
Right.
So it just leaves you with this provocative thought, doesn't it? If a close neighbor like Theia was so unique, what does that say about the true diversity of planetary embryos that must have existed back then? It makes you wonder how many other unique lost worlds we still haven't even begun to catalog.